Hey everybody, welcome to Chapter 9. So today we're going to be learning Section 9.1, which is considered inverse and joint variation. Chapter 9 is all about something called rational expressions, which are just fractions that have variables in them. So with these fractions with variables, we're going to be graphing it, we're going to be solving, simplifying, and today is in this section because something called an inverse equation looks like a fraction, and so it is considered a rational expression. I'll say more as time goes on. Just to get you thinking in the variable format, why don't you look at our warm-up today? I want us to write all four of these as algebraic equations, and here's what I mean. Number one says y is 3 greater than x. Wherever the is where the equal sign is. So y is 3 greater than x. Well, that would be x plus 3. Just to get your brain started on this, please pause the video and try 2, 3, and 4. Alright, you have unpaused and you are looking at the answers right now. We can talk more about those in class if needed. To start off with today with the main part, and we're going to be using the writing equation skills in a little bit, which is why we talked about it, but I'll say more later. Going on to direct variation. I want to review something called direct variation, and I say review because it was in Geometry 2, but it was in half a section in the graphing area. So you hardly really learned it, and so if a lot of you don't even remember learning it, I would not be surprised because it's not covered very deeply in Geo 2. So the reason would be in a graphing section is a direct variation equation is an equation that is linear. Y equals kx is the general format. K is called the constant of variation. K is called the constant of variation. So if they ask you to find K, they're asking you to find, if they ask you to find the constant of variation, that's probably what the directions in the book will say. They're asking you to find K. Let me give you an example quick. So let's pretend I had y equals 4x. Again, look at this. See how I'm saying it's linear? It doesn't have a y-intercept, but if I think of the y-intercept being 0 and the slope being 4, if I graphed this, it would make a straight line. That's always the case for direct variation. If you graphed it, it would be a straight line. I want to show you something, and that is, if I make the table of values, I'm just going to pick some x's, 1, 2, 3, 4. If I take those and plug it into x to find y, so 4 times 1 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. Notice that as x is increasing, y is also increasing. And when I say increasing, it is possible to have a k that's negative. So it's going to be a larger, I'm kind of using the word increasing loosely. It's going to be a bigger number, but it could be a negative and going in the negative direction. Well, anyways, here's what I'm just going to say for a general case. As x increases, y increases. And as x increases, y increases, usually. And here's another way of thinking about it. If I take this equation with k and I just rewrite it, so let me pretend like I want k by itself. To get k by itself, I divided by x. K is equal to y divided by x. So you can tell if something is direct variation if I do y divided by x and I get a constant number each time. Let me show you what I mean. Y divided by x, 4 divided by 1 is 4. Y divided by x, 8 divided by 2 is 4. Y divided by x, 12 divided by 3. Y divided by x, 16 divided by 4. So if it's something is direct variation, every single time you look at the x and y's, I should be able to do y divided by x, and get the same number each time. So in this case, my k value is 4. Alright, that is a quick review of direct variation. Now let's learn something new. Inverse variation. So inverse variation, our equation looks like this. Y equals k divided by x. K is still called the constant of variation. What's happening here is that as x increases, y is going to decrease. As x increases, y is going to decrease. Here's my example. Let's use 4 again. Y equals 4 divided by x. Let's suppose I use the same x values I used before, 1, 2, 3, 4. Now when I find my y value, I'm going to take those, plug them into x. So 4 divided by 1 is 4, 2 divided by 4 is 1/2, 3 divided by 4, 4 divided by 4 is 1. So this is what I mean when I say as the x's are getting bigger, the y's are actually getting smaller. That's what I mean when I say that increases, that decreases. Now let me tell you something really quick. I've got two things to say. First of all, when you're looking at this in your textbook, sometimes inverse variation throws students off because there's actually two different ways I could request this in words. So your textbook might say y varies inversely with x. Y varies inversely with x. Or your textbook might say x and y vary inversely. Both of those mean the same thing, y equals k over x. So this is confusing to students because the first way you could potentially write it, the y comes first, and the second way you could potentially write it, the x comes first. So we're going to practice those, but I just wanted to point that out because the book usually uses this one, but not always, so you might see this other wording in there too. Alright, then you know how before I rearranged it so it was equal to k? Let's do that again this time. So if I want to get k by itself, I want to get rid of the x. So it looks like k equals x times y is the other way of saying this equation. K equals x times y, and again I got that just by multiplying both sides by x to get k by itself. The reason this is significant is I just want to show you something really quick, and that is this time if I do x times y, I should get the same answer each time unless I make a mistake, which I did. Well, I'll show you in a second. I made a mistake with the second one. Okay, but 1 times 4 is 4. And now with the second one, some of you probably caught this earlier. What did I do wrong here? Do you see it? Okay, I should have had, according to the equation, it was 4 divided by x. I did x divided by 4. Sorry about that, guys. So it should have been 4 divided by x, 4 divided by x. Alright. Now, I could catch my mistake because I could see that when I was going to do x times y, it wasn't going to be the same thing earlier, so I knew I did something wrong. Alright, x times y, 3 times 4/3 is also 4. 4 times 1 is also 4. So this time, if I do x times y, I should get the same number each time. And that's still called the constant of variation, even though it's inverse right now. Alright. For example 1, we're going to determine if each of these situations is direct variation, inverse variation, or neither. My first hint is to rewrite so it's y equals something, because that's what both of our equations look like. Y equals something, y equals something. And the other thing I want to point out is I don't have any plus signs in here or minus signs. All I've got is here it's multiply, here it's divide. So if I look at example 1, these ones that have plus signs or negative signs, immediately I know that is not either my situations. So those ones we know are both neither, not direct or inverse. So let's figure out the other ones. So again, we want to try to get y by itself. So when I look at part A, I'm going to multiply both sides by 5. Alright, and then I have to ask myself, does that look more like direct or does that look more like inverse? It looks more like direct, so my answer is direct variation. And sometimes you might have a fraction for k, but the way I can tell it apart is here x is on bottom, and here x is on top, or just with the number. So specifically, x is going to be on bottom for it to be inverse variation. Let's look at C. Alright, and when I try to solve for y, this is what I was talking about. When I try to solve for y, so I divide both sides by x, x is on bottom. That's what you need to have inverse. Let's look at D. Again, let's try to solve for y. Ooh, when I do that, already some of you I bet can see this. 18 divided by 2 is 9, and now again, x is on bottom, so inverse for part D. E, I'm going to divide both sides by 3 to get y by itself. And now don't be thrown off by this. See how x was on top to start off with, and I divided by 3, but really x is still on top, it's not on bottom. Even though this is a fraction, that's okay. K can be a fraction, but x is on top. It's not on the bottom. It's not specifically on the bottom of the fraction, so this is considered direct variation for E. We're going to move on now and write some inverse variation equations. And they don't have writing any direct variation equations in here for the most part because that's supposedly the review part of it. Alright, so for example 2, there's two things we're going to do. We're going to write an equation relating x and y, and then second, you're going to find a value of y, and they'll give you some sort of x to use. Alright, so in order to write an equation, we need to know x. Not x, we need to know k. So the first thing you're always going to do is find the k value. I know it's inverse variation, so here is my formula. What we're going to do is we're going to plug in the x and y they gave us. So they said y is 8, and they said x is 3. So y is 8, x is 3, and now let's find k. So just solve for k like you normally would. So in this situation I got a 3 on bottom I want to get rid of, so I'm going to multiply. Okay, k is 24. That is not our answer though, because I have not created an equation. All I did is found k. I have to create an equation if I'm going to try to get full credit. And that's the number one mistake I see when we do a test on this, is that students don't remember to actually create their equation. The equation would be me just leaving y and x is y and x and just plugging in k. So that's my first answer. My second answer is what happens when I plug in. I'm going to use that equation I just made, and I'm going to plug in x is -4. And this, as long as you have your equation correct, that part should be super easy. So I plugged in -4 into my equation I created, y equals -6. Please pause the video and try B. Actually, you can try B, and then on the next page, C and D are the same type of problem as well. So pause those and try B, C, and D. Alright, you have unpaused and you're following along with me for part B. So just a quick recap again. Step 1, find k. I specifically used this formula because it told me it was inverse variation. I plugged them in, used some calculator if needed, and I got k was 9. So this is my first part of my answer, y equals 9 over x. And then to find the second part of my answer, plug in 4/3 for x. Again, use your calculator if needed, but I ended up with 27/4 for your final answer. Alright, flip to the back and check your C and D for me. First answer, second answer, first answer, second answer. Alright, write down any questions if you have them, and then join me for video 2 for the rest of this lesson. Hey, welcome everybody to 9.1 part 2. So in this part we're going to talk about joint variation and then kind of bringing it all together by writing different equations for inverse, direct, and joint. Alright, so for joint variation, it's called joint variation because there's more than 2 variables, usually 3 or 4. Here's the general format. Z equals kxy. K is still the constant of variation, same as it was before. And this situation, if I was going to say that in words, I would say Z varies jointly with x and y is how that would be said in words. Z varies jointly with x and y. And then the other thing you need to know is joint variation is actually also direct variation. So joint variation is when a quantity, your choice whether or not you write this down, but when a quantity varies directly as the product of 2 or more other quantities. When a quantity varies directly as the product of 2 or more other quantities. So the key word is it's direct variation really, but they're multiplied together with the k. Alright, so now let's talk about the difference when you're trying to make equations for these. So if it says y varies directly with x, that means that the x is going to go with the k. I'm going to say, quote, on top. Sometimes there's nothing on bottom, but it's going right with the k. If you see inversely, that's when the x is going on bottom of the fraction. And if you see jointly, it's also on top. Let's do some practice. Look at example 3. So if I see h varies directly with k, and there's always, or sorry, it says h varies directly with x. There's always a k there. Directly with x means x goes right with the k. That's what I meant when I said on top. It doesn't really make sense to talk about a top and bottom because there's nothing on bottom, but really it's like a 1 on bottom, if you want to think about it this way. Okay, so let's look at B. Z varies inversely with A. Alright, varies inversely means it goes on bottom of the k. Part C, Z varies jointly, X varies jointly with Z and H. So every single time it's going to follow these patterns. It's just going to be different variables, and it could be squared variables or all sorts of different stuff. So let's do D. So Y varies inversely with the square of X. So first of all, inversely means it's going to be on bottom, and there's always a k there. The square of x would be x squared. So my equation is y equals k divided by x squared for that one. Alright, let's go more difficult. Look at E. Now, z varies directly with y, inversely with x. So that means y is going to go on top with the k, x is going to go on bottom. Z equals ky divided by x. Part F. Y varies directly with x and inversely with z squared. So directly with x, inversely with z squared. Let me rewrite that so it looks a little nicer. So kx divided by z squared. Part G. Y varies jointly with x squared and z. So remember, jointly is where it means it's just on top or just right next to the k. So k x squared z for that one. Last but not least, y varies directly with the square of x, inversely with z. So again, inversely on bottom, directly on top with the k. Make sure you write down questions if you have any on that. And the last part of our lesson, example 4, is to write a joint variation equation for a given situation. And this is actually very similar to what we did with example 2. Only this time I'm using my general joint variation formula. So they're going to give you this fact: z varies jointly with x and y. We know x, y, and z. We're supposed to write an equation to start off with. So this is a thing again where we're going to first find k. We find k by using our formula. I'm going to plug in z, x, and y, and then I'm going to solve for k. So when I solve for k, I have 8 equals k times 8 divided by 8. K is equal to 1. So first find k, but that's not our answer. So our answer is only when I take my equation and plug in k. So z equals 1 times xy, or you could just, in this situation, since it's 1, you could just say z equals xy. But that is my first part of my answer. Now, part 2, just like we did with, for example 2, they're going to give us some variables. In this situation, they gave me what x was and what y was, and we're trying to solve for z. So x is -3, y is 5. When x is -3 and y is 5, it looks like z is -15. Alright, part B, similar situation, just a little bit more tricky numbers. So again, it says z varies jointly with x and y. That means I'm using my general equation. I know that x is -6, y is 3, z is 2/5. We're supposed to write an equation. So again, I have to find k, and my goal is to figure out what k is and then plug it in right here. So let's go for it. So z is 2/5, x is -6, y is 3. All right. -6 times 3 is -18. And then I'm going to divide off the -18. So really what's happening is I end up with -1/45 for k. Alright, so there is my equation. That's a negative sign. It's just going into my fraction bar. Alright, and then part 2, solve for z when x is -3 and y is 5. So same thing we did before, just plug in x and plug in y, and then I'm going to figure out what that is. And I end up getting -15 over -45, so that would be 1/3. Alright, make sure you write down your questions. Thanks for listening. We'll see you in class.